My name is Arkadiusz Kowalski and I'm about to talk about my Internet of Things project. I'm using the Mbed K64F microcontroller with the application shield on top. The K64F is connected to an Ethernet cable and the power source serial port cable with a attached NFC module version 3. The purpose of the system is to track the users as they go in and out from the building. This is where people can tag in and tag out as they leave and enter. The system allows tracking, so therefore if you want to see if someone's in the building, you can simply access the service provided using a website, which will then display who is inside the office or not, or the building. The system is pretty useful as you will be able to track whether an employee or anyone else is inside of the building before you start looking for them. It can also be used for other monitoring purposes and analysis. The K64F does everything required for this part of the assignment as it publishes the unique user ID of the user's NFC tag, which is then sent to the MQT server. The K64F does everything required for this part of the assignment as it publishes the unique user ID from the NFC tag provided, which then publishes the ID to the MQT server. For the next assignment, I will be dealing with data processing and visualization of the project, where the user IDs will be added to the system or recognized, projecting who's in the building or how many people are currently inside. The video illustrates how the microcontroller works. As you can see, I have just reset the K64F, which is then straight away connecting to the network, obtaining the IP address and shows the status if it's connected. Then it simply connects to the MQTT server. As you could just see, I have just scanned the card, which blinks the LED at the bottom and projects the unique user ID on the LCD screen. Upon scanning the tag, the fitted buzzer buzzes indicating the card has been scanned. Using an MQTT lens, I can visualize whether the data has been sent to the MQTT. As you can see, the messages are different unique IDs, which you will see when I illustrate further down the video, scanning different tags, producing different messages that have different user IDs. The K64F works in different power states where scanning using the NFC module for NFC tags, reading the user ID and sending it to the MQTT server. The microcontroller is awakened by using the interrupt upon receiving anything from the NFC module indicating I have successfully read a card. I'll sleep in the power saving mode. So this is the code review of my Internet of Things assignment 4, where I review the code used in my K64F embed. I have used some of the libraries provided on Moodle by the Module Convener of Advanced to aid me into production of my code, which has the working system now. To begin with, I have used some of the libraries for MQTT to work with the embed.h and the NFC, which is PN532. I began by initializing the LCD host, LED, LEDMC, and the triggers, so a button on the microcontroller, along with the buzzer and the NFC module. So these are the pins and like access to the part, which is the LCD and so on. I have functions which are used as type definitions, which are used for the MQTT, and there's the config for MQTT obtaining the hostname port topic that it will be used, in this case publishing to this topic, and the client ID of the device, so K64F. I have two methods: reset chip, resets the NFC, and the interrupt, which sets the flag upon pressing. I have a show status method, which basically shows stuff either to the host, which is the PC or whatever it's connected to, and prints on the LCD, so the user can see what's happening in the system as it's running. I have a setup method, which is run in the main method, so I talked about it when I get there. So looking at the main method, I have fields in the beginning, setting up the switch, so the button, what happens when I press the button and release the button, and initialize the flag to a 0 as the program runs. I have some fields that are used further down in the main method, and the array that stores the user ID along with its length. There's a NFC config method from the library, and the setup method. So go up, here it is. So straight in the beginning we have a host.board with the host speed. The host speed is defined above, which is 38400. Is the transmission rate between the device and the host, which is most case PC. Okay. And initializing some of the variables along with the LCD, and reset chip, so the NFC restart method above, and begin NFC, so start working, get the firmware. This is a check, so if it can't find the NFC attachment, it prints the message. So defensive programming, I guess. Back to the main method, we have show status, so the method before, which shows messages of what's happening. This is sent to the LCD. Straight after, we begin to obtain the Ethernet connection and obtain the IP address from the connection. So we get internet access, which shows status, print, what's happening, if address found, if address not found, and starting to connect to the MQTT. So Ethernet connect, and then MQTT config connect. Down below we have if internet connection is there, clean the screen and say we made it connected. Okay. Wait on the thread and connect data initializer. So initialize the MQTT packet connection data. Clean, okay. Clean. Okay, so the data that the client has connected, and when connected, show MQTT has successfully connected. This is a method that checks whether we have the connection, and which we do. There's another while loop checking whether the flag is set on or off. So the button that I have, whether I press the button on the ak643, it can put the microcontroller to sleep, or that has the SW2 trigger, or it will carry on normally. So as I initialize SW2 to 0, it goes in here saying, no, I initialize it to 0, so it carries on saying I am not sleeping yet. It iterates through the whole main method and loops back. As at the bottom of the method, I have set the flag back to 1 for power saving. It is stuck here reading the NFC, and upon reading the NFC, it sets another boolean that I have found something, which is checked here whether I should sleep or not, and sets the trigger to 0 to get out of the while loop. This is so basically if there's nothing, the NFC does not find anything, it gets the checks done and goes back to sleep. But when the NFC finds something, it changes the Boolean states and carries on with the rest of the code. As you saw before, upon reading the NFC, so success, I have read something, turn the buzzer on and the LED print the user ID on the LCD, so the user ID of the tag, the NFC tag scanned, is printed on the LCD screen. And down below we are forming the message that will be stored in the buffer. This will be the user ID obtained, which it's in hex and it's in 2s, so we have to fit them in, so hence why there's 4 here, 0, 1, 2, 3, 4, as it's 8 digits which is in 2s, so 4. This is some defensive programming and robustness, I guess, more robustness, as different cards have different user ID lengths, so I've made it for 8 and 14, and else failed to connect to MQTT. So else if nothing happens, and carry on, and else if failed to connect to MQTT, which it usually if it has internet connection, it will usually get there, but there are checks after. So we turn the buzzer off, we wait 100 milliseconds, we turn the buzzer off, and wait until card is taken away. So it checks whether the card is taken away, then puts the LED off back to where it was. PN promptly timed out, waiting for card. So when this is the standby mode screen, or whatever you want to call it, it shows reader is ready, scan me. So when it's all done, is finally ready back, and prints the message to the host saying I'm currently waiting for card, nothing's happening. Gets the LED off, waits 200 milliseconds and sets the trigger to 1, so it will be in its sleeping state again. These are some checks, so show status, so what's happening if it fails to connect, wait, and fail to connect to MQTT, prints a message if it fails, or fails to connect to TCP if it doesn't have internet connection. This is Ethernet disconnect, so at the end is closing the socket when not using the Ethernet anymore. I initially created this with an interrupt, so I would put the microcontroller back to sleep when with a press of the button, but I have decided to create it so it's always sleeping until the NFC reads something. So upon receiving the tag, when the NFC receives something. For this part of the assignment, I believe I have everything I needed, as all I needed was basically to get the user IDs of the tags and send them on to MQTT, where after that, in the next part of the assignment, I will be doing the data processing, so finding out, according to my plan, who is inside of the building or not, and the visualization, therefore after creating a web page and so on. The code for this is fairly simple, as it does exactly what I needed and no errors so far. I have some defensive programming success here, so when the card is released, the boolean is set to 0 as well. I have used the libraries provided to help me, and that's about it. So for the last bit of the assignment, I would like my project to be marked on defensive coding, data processing, and other, and MISC. Yeah, should be fine. Thank you.